Well, as I mentioned earlier, the world has a severe shortage of labor. And the reason why humanoid robotics is so important is because it is the only form of robot that can be deployed almost anywhere brownfield. It doesn't have to be greenfield. It could fit into the world we created. It could do the tasks that we made for ourselves. We engineered the world for ourselves, and now we could create a robot that fit into that world to help us. Now, the amazing thing about human robotics is not just the fact that if it worked, it could be quite versatile. It is likely the only robot that is likely to work. And the reason for that is because technology needs scale. Most of the robotic systems we've had so far are too low volume. And those low volume systems will never achieve the technology scale to get the flywheel going far enough, fast enough, so that we're willing to dedicate enough technology into it to make it better. But humanoid robot, it is likely to be the next multi-trillion-dollar industry. And the technology innovation is incredibly fast. And the consumption of computing and data centers, enormous.
Scott, your response, your reaction to what we just heard from Jensen.
Okay, first I think there's two very important points he makes there. The first, brownfield versus greenfield. So a brownfield means you're taking an existing factory and just kind of putting some things in there. And a greenfield is that you can completely design it from scratch. So if you're going to do greenfield and you're going to do 100% automation, yeah, you can create the space such that you don't need any humans in there and have bizarre form factors and everything else. But if you want to be able to do kind of a drop-in thing, which is what most factories do, is they're constantly evolving over time, improving production, everything else. You think to automate. Sometimes when you bring the automation in, it requires like major reconfiguration of what you have out there. And now to give you an idea, he's also talking about the volumes and stuff like that. So we all know that industrial robots have been around for a while. Royden, do you remember when the first industrial robot actually went into use, when that was?
Probably in the 70s, late 70s.
No, 1961. So it was 1961.
Before I was born.
Right. Unimation and Joe Engelberger's company put the first Unimate 1 robot in a GM plant in Trenton, New Jersey. That's 1961. So here we are about, 64 years later. And do you know how many industrial robots, and this is including all the industrial robots, like cobots and stuff like that, are produced worldwide right now? You know how big that market is?
Probably over 1 million at least. I mean, if you take all sorts of industrial sectors together, manufacturing sectors.
It's about 500,000.
500,000, okay.
In that long time period,
with Optimus.
We've taken we're just barely at 500,000 with that, okay?
Yeah.
So what Jensen is saying is it's low volume. The reason it's low volume is that they don't sell 500,000 robots a year. They sell 500,000 robots, one robot at a time a year. Each one of those robots requires so much customization. That's why you're not seeing tens of millions of robots being sold a year in the old school way, because it requires a lot. Well, look, if you go into a manufacturing facility that's got, we've automated lathes and milling machines a long time ago. I mean, starting in the 50s is when you had CNC machines. But there's one thing about that automation is you always need machine tending. You need someone to be able to load a part and unload a part and do all these other things. And we try to automate that. We've done that with standard industrial robots. And what we end up doing is fencing them off and putting these rails on the ground with a robot that goes around there, because these cycle times are really, really long. If anyone has a 3D printer at home, the 3D printer is a lot of work, but until someone comes down and takes the part out, it can't go ahead. So you need to have that machine tending. And the idea here is I want to automate that now. Rather than having to put down this rail and getting this industrial arm with a weird gripper and all this other stuff, let's just go ahead and drop in a humanoid to go ahead and do what I'm already doing. And what that means is the only ones who are automating let's say the machine tending are the really big guys. You get down to these small scale guys, they can't afford to do that in many cases. Or it's an extremely simple one where it's just one machine tool and the account's doing the same thing back and forth. But what Jensen is saying is right on, that the problem with the volumes is it's too hard to scale, and you want to be able to drop them in place.
Yeah, and it doesn't get more generalized as a form factor than the human form in a world built by humans for humans in manufacturing. Let's get the good doctor in. Gustav, are we ready for that tectonic shift? We've been discussing, a lot of the early signs for a while now here on Over the Horizon. But I've been listening to what Jensen said, at ComputeX. It just seems as if I think a lot more people need to understand that this tectonic change, this transition is already on.
Yeah, and I guess we're seeing it to some extent, but most of the times it's a bit gimmicky when it's from my world of healthcare. So there are some examples of like attending nurses, robots from the Southeast Asia region, and here in Sweden we have these robots running around in the basements of our hospitals transporting equipment, and there are a bunch of these funny clips where the two bots meet each other and they ask each other very politely, please remove yourself from my path, and it just keeps on repeating and they get stuck. So I think that a lot of people are quite skeptic as they haven't really seen it pan out in reality. But I'm definitely seeing the potential here, and the way NVIDIA is presenting their products and their open sourcing of all of these training systems that we will talk about today, it gives me high hopes for the coming years.